Alright, here we go. So Unit 2, Skill 7. How do we answer questions where skills 1 through 6 are applied in one question, basically. Kind of a review mixed all together, and it gets kind of challenging when they're all together like that. So here we go. Is the following a function? And the answer is going to be yes. And we need to be writing. The explanation, why is it a function? It passes the vertical line test, and there is one y for each x. So passing the vertical line test, when we draw that vertical line anywhere on here, there we go. It's still off. It passes the vertical line test. So, one y for each x. There's one y value for each x value, or one output for every input. Another way of saying that. Is it one-to-one? So for it to be one-to-one, it has to be both a function and the inverse must be a function. So we have to do both the vertical and the horizontal line test. So the answer is no. Obviously it passes the vertical line test, but we draw a horizontal line across and it just don't work. Okay? So we say no, and if the horizontal line test is not working, there is not, no comma, not 1x. That's supposed to say 1x for each y. Again, that's supposed to say no, we do not have 1x for each y. State the domain and range in interval notation. Interval notation, okay, so that's the one that looks like this or like that, something like that, okay? So domain is how far left and right, so we start tracing back and forth. How far to the left does it go? How far to the right does it go? I don't care about up and down in this particular case, it's domain and range. So the domain goes left and down, but it goes left forever, so that would be negative infinity. So the domain is negative infinity. To the right, it goes right forever as well. It's going this way forever, so that is positive infinity. The range. Okay, the range does not go up and down forever, which would be nice. Okay, we can say negative to positive infinity. That's not happening. So the range, it goes down forever. So the lowest value as it goes down, over here or over here, doesn't matter where it's going down, it goes down forever. The lowest value is negative infinity. The highest value, start tracing across as you go up, as you go up, as you go up, as you go up. It stops right at this line right here and just start tracing across. How far up is that? Well, it's right here, which is the x-axis, which is a y value of 0. Range is one of the few times where we actually care about the y value. For the most part, we only care about x. Alright, so what am I doing? Goes up to 0. Okay, now, I made a minor mistake there. It goes up to 0, I just said it, and it hits 0, that implies it. So this bracket should be kind of closed off. So since I can't erase because I pushed a different button, I have to kind of fix it that way. Part D, state the intervals of x where the graph increases or decreases. Okay, so increasing and decreasing, this is where we get mean and we only care about the x value. So where is the graph increasing? So as I go from left to right, okay, if you need to write that down, write it down right in here. As I go from left to right, what's happening? And notice it says the intervals of x. Again, I don't care about y. So go from left to right, it's going up first, and then it starts to go down. So this value right here is kind of important, wherever that value is. The x value, that is. Alright, so it starts off, every value over here, it's increasing. So that's all the way from way back over here, even off the paper. That's negative infinity. So way over here, it's still increasing. It's going up, it's going up, it's going up until we hit here, until we hit that negative 4 value. So we are increasing from negative infinity all the way, that's supposed to be negative there, all the way up to negative 4. Now we can't be increasing at negative 4 because at negative 4 it's kind of starting to go back down. It's the very peak of it. It's not really going up or down. It's right in between. It's in limbo. So it doesn't hit it, which is why we have the parentheses. We don't have the closed bracket. We are decreasing, where the graph is going down as we go from left to right. So notice from negative 4 on, it's always decreasing. So that's from negative 4 to what? What kind of infinity is the question here? And a lot of people get confused. So the low value is negative 4. So what's the high value? What's it go up to? Okay. Well, a lot of people want to say negative infinity, and that's because they're going down the graph. But I only care about x value. So as I go down, my x values keep going to the right further and further and further and further. I keep going across this line. My x values get larger, which is positive infinity. All right, state the intervals of x where the graph is positive, is negative. All right, well, positive and negative is nice. Because, well, it's just where it's above the x and below the x-axis. And you do have to be careful here. So in this case, it is pretty much negative the whole way, with one small exception. It is not negative right at that one spot at -4. So it's not negative right here, okay? Because it's on the x-axis. Very common mistake is for people to miss that. So we have to give an interval that represents over here where it's negative and over here where it's negative. Okay? So it's not positive anywhere, so we can just say negative is the only answer we're going to have. The first interval is all of the x values, and I'll trace it up top over here, and then all of the x values over here. So we're going to go from negative infinity up to -4, and union -4 to positive infinity. Now, a much faster way of solving that question without using interval notation would just be say everywhere but -4. So you could say all reals except when x equals -4, and you'd be good to go. Describe the end behavior in formal notation. So you need to have this written out. You need to say as x approaches something, right, positive or negative infinity. I like to do negative infinity first. F of x, right, approaches something, okay? So as x approaches negative infinity, as we go left forever, as I go left forever, what's it doing? Oh, it's going down the page, so it's approaching negative infinity. So as we go left, it's going down forever. Okay? So then the next one, as x approaches positive infinity, which is just saying as I go to the right forever. Okay? So as I go right forever, what's happening? So I'm going right forever. What am I also doing? I'm also going down forever. That graph just keeps going down and right forever. So as I go right forever, I'm also going down forever, which is the same, kind of the same as what we just wrote. So as x approaches infinity, f of x approaches negative infinity again. Is the graph even, odd, or neither? Now, people might look at this and say it looks like it is one of those, right? Even versus odd versus neither. So even is a reflection over the y-axis. Odd is if you flip the thing upside down or rotate it about the origin. But just flip your paper over upside down if you really want to know about odd. And yeah, if it looks the same, it's odd. But in this case, it looks like it might be even, but it's not reflected about the y-axis. It is just a reflection over that line, x equals -4. So it is neither because it's not symmetric about the y-axis or the origin. Or you could say it's neither because it's symmetric about the line x equals -4. So neither, comma. And this explain part in a math problem is important. So it is not symmetric about the origin or the y-axis. Being able to write legibly is also important, which I cannot do on this smart notebook. I'm so sorry. That was me trying. You can laugh a little bit because that's just pathetic. So neither, it is neither even nor odd. Odd because it is not symmetric about the origin or the y-axis. You could just say because it's symmetric about the line x equals -4, that doesn't really explain what the other two are. Okay? And that's that. Let's move on to another question. Alright, here we go, round 2. Took too long last time. I'm going to try this video again here, this page. Is the following a function? The answer is yes. Why? Because it passes the vertical line test. 1y for each x. So 1y for each x. Is it 1 to 1? The answer is no. All right, you draw a horizontal line up here, and it crosses more than one, so there is not one x for each y. No, not one x for each y. State the domain and range in interval notation. So the domain is how far I go from left to right, so it looks like that's the farthest that way, and it goes up and down forever. The range, what's the lowest I go, what's the highest I go. Okay, so the domain. My farthest leftmost point is negative 3.2. It is an open circle, so it can hit it. So we use a closed bracket, negative 3.2 up to infinity. The range, again, how far up and down? Well, the lowest I go down to looks like right here. All right, that's a y value. The range is the one time we actually care about y, which is negative 2.6. Since it hits that point, we have a closed bracket right here. This is a closed bracket because it can touch it now. The range goes up to infinity. You can never touch infinity, and you're good to go. State the intervals of x where the graph increases and decreases. So it is increasing as we go left to right when it's going up. So here is where it's increasing first. Here is another interval, and here is the last one. So we have three answers as to where it's increasing. That's a real pain in the butt, but it is. So again, I only care about x. So what are the x values that I just shaded of this blue area? That's what you want to find. So the first x value that we have is negative 3.2. Okay, come on. The next x value in that area is going to be right there, negative 2.2. At negative 2.2, you can see that it's the turning point from where it's going from up to down, okay, increasing to decreasing, which means it is neither increasing nor decreasing. Depending on the book that you jump into, you can be told that this last point right here is either increasing or we just don't know what it's doing. But the AP labels it as an increasing point. So if you were to take AP Calc, I'd want you to get that right. So we're going to say that it is inclusive there. So we close it with a closed bracket, which indicates that it is increasing at this point. That's how AP labels it, closed bracket. So we're going to do it that way. But again, there is a lot of discussion about that, a lot of different books, and it's way past our pay grade. It isn't that important. So the next place where it is increasing is right in here, and again, I only care about the x value. So the first x value is 0, the next one is 2. And then the last spot it's increasing is going to be an x value from here over. And there is no x value over here because it's going up to infinity and beyond, so it's going right to infinity and beyond, so the lowest value is 3.5 to infinity. And again, 3.5 is a turning point, so that's why it has an open bracket right here, because we can't say it's going up and down at the same around it. So it's a turning point, and infinity you never touch. Decreasing. Alright, well, it's decreasing here and here. So decreasing, we need to say the x values again. So the first x value in this interval that I've shaded where it's decreasing, what's the x value again? I do not care about that 3.1. The x value is negative 2.2, so from x equals negative 2.2 to x equals 0. Okay, and then the last one, again, the x values are going to go from an x value of 2 to an x value of 3.5. Again, I don't care about y. I don't care that it went from 0 to -1. Yes, it did decrease from a y value of 0 to a y value of -1, but I'm only going to give the answer in terms of x. It's just for uniform sake, so that everybody is talking in the same language. So we always use it. Okay, so where's the graph positive and negative? Notice I've erased the lines where it was increasing, decreasing. So positive and negative. Where is it above and where is it below is all we really care about. So again, I'll use blue for where is it above. It's above right here, and it's above over here. So positive. It is positive at the x values of, we're not going to give the y values, so only the x values. So what are the x values in between here and here? Well, that's from -3 to -1. Okay, and then the other x values that we have at positive are right over here. So again, the x values, I don't care about the fact that it's going up, it's just above. So that's these x values going all the way over. So from 4 to infinity. Now, answering the question of where it's negative is kind of mean. It is negative here. Okay, it is negative in here. It's not negative right here. And then it's negative again right here. So we got to be careful. Alright, so negative. Alright, so what are these x values in here? Well, the x value here is -3.2. Closed circle, so it can hit that. Oh, that's the wrong one. Sorry, guys. So it can hit the -3.2 and be negative there, inclusive. But at -3, it cannot, because -3 is on the x-axis. That's neither positive nor negative. The next interval that we're going to have, the next bunch of x values are going to be in between here and here. So what's that x value there? Well, that must be -1 all the way over to that x value of 2. So -1 to 2. And then the last interval that we're going to have is going to go from the 2 right here all the way over to this 4. And again, at the value of 2, alright, it is not positive or negative because it is on the x-axis. It's 0. So 0 is not positive or negative. End behavior. Alright, so the end behavior and formal notation. This one's a little bit weird. I have to kind of apologize for this one. It's probably a question that you won't see on this Regents. I would bet a lot on, and not one that I'm going to throw on, but we'll talk about the end behavior anyways. So as x approaches, well, x doesn't approach infinity or negative infinity, but x does approach the farthest left that it goes. If you take a look up here, the farthest left that x is -3.2. So that is the end behavior for this one. So as x approaches our -3.2, according to this graph at least, what does the y do? Well, the f of x, or y, approaches the y value, which is -2.6. Again, not a question I think that we're going to see. Alright, and not one that I'll put on. As x approaches positive infinity, what's f of x doing? So we look up here, as we go right forever is what that's saying. It's f of x, as x approaches positive infinity. As we go this way forever, what's happening to the graph? Well, you can see that it's going up forever. So we can say f of x is approaching positive infinity as well. And then the last question, is the graph even, odd, or neither? And explain your response. Well, it's even if it's a reflection over the y-axis and it looks the same. That's not going to work. It is odd if you can flip your paper over and it looks the same, which means it's symmetric about the origin, and that's not going to happen. So this is neither even nor odd for those reasons right there. So not, I'm going to write neither, because it's not symmetric about the x-axis. Yep, I'm at y-axis. Let me change that. Not symmetric about the y-axis, I apologize. Or the origin. So it's not symmetric about the y or the origin. Now your summary here is going to be, a little bit lengthy. I mean, you have to summarize function notation, one-to-one, whether, domain and range. Is it increasing or decreasing? Is it positive or negative? Even versus odd, and end behavior. So you might have like a bunch of quick one-liners here, bulleted form, for your summary. Thanks.